Okay, so let's go over this warm up. And what I want you to do, I'm going to ask for some participation. You guys ready? If you think it is nonlinear, give me a thumbs up, okay? A thumbs up with the virtual thumbs up. All right, sweet. Is that like a preemptive? Got it? Or is this part A? Okay. Some of you guys jumped the gun. All right, let me wait a minute while the reactions go away. Let's see. I'm going to be able to see as many people as I can. There we go. That's better. All right, ready? Part A. Is this non-linear? 1 over x plus 2 greater than 3. Is this non-linear? Yeah, 1, 2, 3, 4, 5, 6, 7, 8. Okay, several people. A beer. Is that like no? Is that your no face?
Yeah, it's because I think it's linear.
All right. All right. And you think it's linear, I'm guessing because the x has a power of 1?
Yeah.
Yeah. The problem is, though, where is that x at?
Oh, it's in the denominator.
It's in the denominator. Okay. So this is nonlinear. Because x is in the denominator. Okay. So, all right, let's look at part B. Is this nonlinear? And I like the oh no face. If you say no, you can say no. But if it's nonlinear, it's thumbs up. If it's linear, which seems weird, this is almost reverse. Oh, I love that little surprise oh no face. Okay, thanks guys. You are correct. This is linear. Because we have a fraction, but everything else, the variables are not part of the fraction. So, and they're not in the denominator. Specifically, they are not in the denominator. All right, part C. Is part C nonlinear? All right, got some thumbs up. Do I have any oh no's? 1 oh no. Okay. Where is the variable? It is inside the root, right? Okay. That means it is nonlinear. Okay, nonlinear. So even though that's x to the first power, the fact that it's inside the root is going to be nonlinear. All right, part D. Linear or nonlinear? So I'll ask it just to be clear, is this nonlinear? Okay, I have 1 no, 2 no's, 4 yeses, 5, 6. Okay. All right. The yeses, the thumbs up have it. That is true. This is nonlinear. And I did try to trick you a little bit, okay? So the first fraction has a 5 in the bottom, which would make it linear. That's no problem. But the second fraction has an x. So this is the part that fails. So it is nonlinear because there's an x in the denominator. If it's in at least one of the fractions, it's going to be nonlinear. Okay. All right, let's look at E. Is this nonlinear?
Yes.
I have yeses. I have a couple no's. Okay. So each piece is linear. Each piece of this is linear. X minus 1 by itself is a line. X minus 5 by itself is a line. X plus 4 by itself is a line. But if you were to multiply this out, you would at least get, you would get x times x times x, which means my leading term would be x to the third. Okay, so if I were to multiply this out, this is actually a cubic. This is a cubic function. And so that means it is nonlinear. Any questions?
Can we just quickly go over what qualifies something as a nonlinear and linear?
Yep, I'll do that at the end. Let's finish this last one.
All
F.
right.
Okay, F. That's a good question. Thank you, Abiel. Which one is this? Is this nonlinear? What do you guys think? Oh, it's mixed. I have a mixed group here. Okay. This x to the second power means it is nonlinear. Okay. So let's summarize a couple of things here. But I need to move this down a little bit. I had to squeeze it in there so it fit. Is it really going to be able to do it? Okay. Pieces of it moved. Isn't that funny? So let me just fix this. Construct assignment for the following functions. And I got all the rest of the stuff with it. Okay. So let's summarize here. Summary. Okay. Linear functions are of the form y equals mx plus b, or we can write it as f of x equals mx plus b. Okay, meaning I can write it in that way. I can get the there's only the power, the highest power is 1. And then also x is not in a denominator. That's kind of like, or a root, denominator or root. Okay. So another way of saying this is you can get it like mx plus b is greater than 0, or whatever it is, less than or equal to 0. These all look like linear functions. And those ones we already know how to solve. You just have to make sure that you flip the inequality when you can isolate x. They're not bad, okay? So like even this one up here, number 2, I could get all the x's and numbers on one side. I would get like 5x and then plus a half is less than or equal to 0. So on part B, if I got everything on one side, I'm sorry, if I subtracted 3x from both sides, I would have negative 5x. And I subtract 1 from both sides, it is minus 3 halves. I'm not going to go through that in detail, just trust me. And it would look like this, less than or equal to 0. So I could get that one to look like that. That's what makes it linear. Okay. Nonlinear functions these guys have higher power polynomials. So if you have x to some power where n is greater than 1, that would be the fancy way of saying that. Okay, so I have a higher power polynomial. So examples like that would be number E and F. And then, or you have the variable in the denominator, or in a root. Okay, these ones are nonlinear. Does that make that better for you, Abiel? Is that more clear?
Yeah.
Okay.
I just need 1 second to write all that.
I'm gonna move this down more. Okay. All right. So here's also something I want to really highlight. In order to solve nonlinear inequalities, we need a sign chart. Okay. So that's why it's important that first of all, you recognize when you need a sign chart. Because if it's linear, you just solve it like you normally would. Like you can just get X by itself. Okay. So now what I want to do in the next part is review, well, how do we make these sign chart things? Oh, look, that piece got like, it's supposed to be down here. Okay. All right, so now let's look at the part at number 2, okay? Now, just looking at this graph, remember that, so recall, what does a sign chart do for us, okay? A sign chart, anybody remember? What does it tell us? It records the signs of the outputs. Okay, we talked about this yesterday, the y values of the function. It tells us which intervals of x values will produce negative or positive outputs. Okay. So let's look here. It really is just a snapshot of the x-axis. So whatever you see happening on your x-axis, like here and here and here, these things need to go on my sign chart. So here's -3 and 1, and then also 3. So we record any zeros and any weird stuff like an asymptote. So let's look at this. So these are called zeros. And just really quickly, what is an asymptote on a graph? What does that mean about the number 3 in our function?
It will never cross
Never
that.
touches.
Never touches. So if I try to put 3 into my function, if I try to plug it in, what happens? And don't forget you
No
have the formula.
solution.
It's no solution. Look at that formula up there. See how it's x minus 3 in the denominator? That 3 minus 3 will make that a 0 in the denominator. So it is undefined. So this is, so x minus 3, I'm sorry, x equal to 3 is undefined. It's not in our domain. That's how we talked about that before. Not in, I scribbled it out like I can't do, okay. Not in the domain, okay. So I'm gonna call this on my sign chart, I'm gonna call it a bad number. A lot of people will also label it as a U. It's up to you. I like to be a little bit dramatic about it. If you put them both on there, it says you bad. So there you go. It is definitely never included. So I'm going to put an open circle here. Okay. Now, let's do some recording, shall we? What can you say? Here's the first interval from -∞ to -3. That's all the outputs along here. This is this interval. So what are we going to record on our sign chart? Is it negative or positive?
Negative.
Negative. Okay. If you pick any point along here, my y value is going to be negative, right? Okay. All right. Now let's go to the next interval from this is now from 3 to 1. 3, that's this right here. That's that part of the graph. Positive or negative?
Positive.
Positive.
Positive. Okay, my outputs are positive. Now, we'll go back from, this is the next interval, from 1 to 3. My outputs are where?
Negative.
Negative. And then the last one is from this 3 to infinity. Here's my function here. These outputs are positive. Okay, everybody see how we pulled that information from the graph? So what this means is, let me ask you this. If x equals -2, what type of output am I going to get?
Positive.
It's positive. Yes. Look, here is -2. You can look on the graph, but you don't even need to. Look, -2 would be right there on my sign chart. It's in the positive region. Okay. What if I put in the number 2? What type of output should I get?
Negative.
Negative. Okay. If I put in -100, what type of output am I going to get?
Negative.
Negative.
Negative. Okay. You guys see how that works? Whatever I put in my function, it's going to fall in one of these intervals. And I know just by looking at the number line, now I have this. I don't even have to look at the graph. I can just know whatever input I put in my function, it's going to give me either a negative or positive output. That's what my sign chart tells me. Okay. So here are some questions. Now let's spend some time interpreting this. Well, interpret the sign chart. Blah. Okay, so here's one. Solve. What if my function, which was, the formula was x squared plus 2x minus 3. What happened there? X squared plus 2x minus 3 over x minus 3. I want to know where this function is going to be greater than 0. And 2, I want to know where this function is going to be less than or equal to 0. So I want you guys to just look at the sign chart. You don't need to look at the graph. See if you can answer that. Figure out the intervals that we would name in each of those situations. Just take like 1 minute and think about it. Okay. How about Sabrina? I haven't heard from you in a while. Can you tell us about number 1? What intervals did you list there?
I just did like the x plus 3 and the x minus 1.
The x plus
Oh,
3.
you're talking about like the intervals for like the notation.
Okay, so you did -3 to 1. And what else? Is that the only one?
And then 3 to positive infinity.
Yes, very good. Now, here's the question. Is -3 and 1 included? Do I use square brackets or open brackets?
Open brackets. And then you would
Yes.
use the square one for the 3 and then an open bracket for positive infinity.
Okay. Definitely here. So let's talk about why these are open first, okay? Notice that this does not include 0.
Oh yeah, I see that.
Does not include 0. So when you're looking at your sign chart, you also have to make sure you're looking at this inequality. So if it doesn't include the zeros, you have to have open brackets. So you said that actually, I think. I don't know if you meant to, but, and then it's going to union. Now here's the thing about the 3, this 3 here. This is not in our domain. So if it's not in our domain, we cannot include it. So that one is open also. So these are the 2 intervals. I didn't like make this one green, but it's this interval where from -3 to 1 and from 3 to infinity. Any questions about that?
So say we had homework and it asked us to make a sign chart. Is that how it's supposed to look like?
Oh, we got more work to do.
Okay.
Yes, at the end answer looks like this. So actually what I'm teaching you guys right now is the last step of solving these, because there's going to be a lot of steps to get to this. But when you get to the end, that part should be easy, okay? But sometimes if we don't spend some time doing this and understanding what the sign chart is telling us, then you screw it up at the end and you do all this work and it still is not good. So so I just want to focus on this part for a minute, and then we're going to go in like a couple minutes, we're going to go through the whole process. Okay. Now, number 2, where is this less than or equal to 0? So i.e. when is this negative? So when are my outputs negative is what this says. When are outputs negative or 0? Okay, that's basically what that's asking. If I'm less than 0, that's the negative. And then because there's an equals in there, it's 0 included. All right, so how about Abiel? What did you think these intervals should be here, Abiel?
Wouldn't it be the same thing, but with the closed, and then it would be, since the sign's the other way, it'd be less than 0. Give me 1 second to
Okay.
solve it.
Okay. Well, looking at the sign chart, Abiel, where do you see negative written? Over which intervals?
Well, -3 and lower, and then between 1 and 3.
Okay. So where, when you say -3 and lower, what is it going out to?
Infinity.
Negative what?
Infinity.
Yes. So, right, this is coming from negative infinity to -3. Do I include -3?
Yeah.
Yes, because of this equal sign right here. Okay, that allows us to include the 0. Then I'm going to union this. 1 is my other 0, so that's included. But 3 is the undefined, so you cannot include that. Okay, so those are the intervals where you have negative outputs or they're equal to 0. So that's just interpreting the sign chart. What is it telling us? Any questions? Okay, now let's do this thing for real from start to finish. Solve. I'm going to do, oops, x over x minus 1 is less than or equal to -2 over x minus 1. Okay, so this guy is nonlinear because x is in the denominator. So we need a sign chart. And I'm not going to graph it. Okay, so this is the for real thing. The graph was just a nice little visual so you could see where we were getting all this stuff from, okay? But now we're doing it for real. All we have is this formula. We're not going to use the graph. And we don't need to, okay? So remember, math is about trying to find the shortest path to the end, even though this is going to take long. It's not as long as graphing. So what we're going to do, I'm going to outline the steps for you on the right side here. So one, you want to get all terms on one side of the inequality. So what I want is I want either all the stuff greater than 0 or whatever my symbol is, I want it to be like that. Okay. So in this problem, I'm going to take x over x minus 1 less than or equal to this negative 2 over x minus 1. So since that's a negative, I'm just going to add this fraction to both sides. Remember, we cannot clear fractions in an inequality. You cannot multiply by a variable. Quickly, what happens when you multiply across an inequality? What do you have to be really, really careful of?
If you're multiplying by a negative or a positive,
Exactly, okay? If you multiply by a variable, the very nature of a variable is that you don't know what it is. It could be a negative number, it could be a positive number. So in a nutshell, and I will talk about this more probably tomorrow because I won't have time today, but quickly, you cannot multiply by x on both sides because you don't know if x is negative or positive, and you could potentially violate the inequality. It's an unknown, okay? So that's why you can't just do that. So we're going to get all terms on one side of the inequality. I'm going to add that. So this is just going to be, since they're the same denominator, I can put it over one fraction, and negative 2 plus 2 is just going to give me 0. Okay, everybody comfortable with that? Any questions about how we got that? If the denominators aren't the same, so if the fractions do not have the same denominator, I guess this is more like a bullet point rather than a step. The fractions do not have the same denominator. Okay, get a CD and combine into one fraction. And we'll probably get to one like that tomorrow. I don't think I'll get one in like that today. But that's what we did before anyhow. It's no big deal. I also want to highlight this right here. Once you get everything on one side and the other side of the inequality is 0, put a little box around that because this is my question. Okay, that I'm going to answer. And it's asking, what is my question asking here? Can anybody say it in words?
What is less than or equal to 0?
Yes. In particular, what's the what? What am I looking for here?
The x.
Actually, that's true, Micah, you're right. So which x values will give, what is this? Go away. Will give y values that are negative or 0. Okay, that's what I'm basically looking for. And you could guess, I mean, we could just start plugging in numbers, but you're going to have a hard time getting them all because you're talking about a whole number line you have to check, okay? All the real numbers we have to look at. All right, so once we have that set, the next step is we're going to write it as a function. And find the zeros and undefines. Okay, so here's step 1. Step 2, So I'm going to write this as f of x is x plus 2 over x minus 1. Because I basically cannot operate on that inequality. There's nothing I can do with it. So I'm going to write it as a function. So this is just a notation issue. But you can get zapped if you don't do this. You can make some pretty bad mathematical errors. So now, to get the zeros, remember the zeros are your x-intercepts. How do you find x-intercepts? What do you set equal to 0?
The denominator.
That is going to be for my undefines.
Oh, isn't it x's?
I want to set the y equal to 0. So to find my zeros, I'm going to set this whole thing equal to 0 like this. Okay. Then, now that it's an equation, okay, you're fine. We can do stuff to an equation. We can do whatever we want to an equation as long as we do the same thing to both sides. So this gives me 0 is equal to x plus 2, subtract 2. This is an easy little linear equation to solve. So here's my 0. So if I put -2 into this function, I'm going to get out 0. And the image you should have in your head when you see this, okay, remember, this is the place where the graph crosses the x-axis. Remember, that's what an intercept is. So here's my x-axis, here's -2. It's either going to like travel across it going from below to above, or it's going to be coming up here and go under. Or I guess it could do this too. It could also do one of these. Okay, it can dip. Whatever the case is, I guess now I didn't tell my other class that. The point is it's going to touch the x-axis at -2. Okay. All right, now undefines. That's where the denominator. Okay, remember undefines are where your denominator cannot equal 0. So x cannot equal 1. So there's the 2 pieces of information I need for my sign chart. So step 3 is draw a number line and place the zeros and undefines on the sign chart. So here's 3. Here's my sign chart. I'm going to put on there -2, which is my 0, and 1, which is my bad number. Now, bad numbers are never included. So one thing that's smart to do is to go ahead and put an open circle there. That should like kind of cue you, like, can't ever include that. Okay. What about my -2? Let's just take a minute and look back at the question. Am I including -2?
Yeah.
Yes, that inequality has an equals in there. So you know what? Let's go ahead and make that like a dark circle because that tells us it's included. Okay. Now, the next step is really important. I don't have my graph to look at. So before, what we would do is look at the graph and see if it's above or below. But I don't have that. So what I'm going to do is I'm going to test regions. Okay. So you choose an X value in each interval, plug it into your function, and record the sign of the output. Okay, so here's my regions. Here's 1. It goes from -infinity to -2. Then I have another region from -2 to 1. And then my last one is from 1 to infinity. So I have 3 areas where I need to check and see, is my graph above or below? Okay. Now, some people like to do it right under. I don't care how you organize this part, but remember my function was x plus 2 over x minus 1. Okay. So I need to pick a number between -infinity and -2. But not -2, because -2 is going to give me 0. That doesn't tell me anything. I already know that. So I don't know. I'm going to pick like -3. So let's do that. Let's pick x equals -3, because that's in that region. So f of -3 is going to be -3 plus 2 over -3 minus 1, which is -1 over -4, and negative over negative is a positive. So remember, I don't really care what my output is. The number doesn't really matter. I just know that this is going to give me a positive output. So what that means is all that graph is above the x-axis. I don't know how, I don't know what it looks like, but it's above. Everybody cool with that? All right, now in region 2, what x value should we choose in region 2?
0.
0, yes. Anytime you can pick 0, take 0, right? So x is 0, so f of 0 is going to be 0 plus 2 over 0 minus 1. And that's going to be 2 over -1, which is -2, and that is negative. So this region is going to have negative outputs. Now my third region, I just got to pick something bigger than 1, so I'm going to pick 2. So f of 2 is 2 plus 2 over 2 minus 1, which is 4 over 1, which is a positive 4. So that region is positive. And now we have a sign chart. We didn't even need the graph. Any questions about that? Okie dokie. So last step. Oh, we're on, I don't know why this is I guess 4 testing regions. I'm just numbering stuff, just to try to keep it in order. Last step is answer the question. Okay, so we did all this work to get this sign chart, but so what? What is it? What's the purpose here? What's the point of all this? Well, let's go back and look. This is why I boxed this little thing in here, okay? The question was asking me, where is the output's going to be negative or 0? Okay, so my question is this. Let me just put it down here. I want to know this. So what do you guys think? Which region are we going to pick?
Close -2 and 1.
Yeah, -2 to 1. It's this one here. This is what it's asking for. So my solution is all the numbers from -2 included, because we already, like, it's this equals, to 1 not included, because this is the bad number. So if you pick any number from -2 to 1 and plug it in that function, you'll get a true statement. Any questions? So you guys can see it's a lot of steps, right? It's a lot of steps. But the final part's easy, I think, once you get your sign chart done. You just gotta like answer it. Are you guys excited? I think this is fun. I don't know.
I have a
It's just
question.
too many steps. There's a lot of things you can mess up on. I feel like when there's a lot of steps.
Yeah, there's a lot of places to make mistakes. I think the key is you gotta know your steps, okay?
So
Well, let's
on a
review.
quiz,
Want to review for a minute? Go ahead.
on a quiz or a test, do we have to do like all 5 steps, or
You have to show all your work.
yeah?
If you skip
Oh.
steps, it's going to be harder. Now I really like, on the right side especially, I wrote out everything in words so that if you review this, you can look back and see, okay, why am I doing it? What am I doing? When we do some more examples tomorrow, I'm not gonna like spell it all out. I'll just go through things a little more quickly. Okay. I don't think you have homework on this tonight. I think tonight's homework is the graphing and the completing the square, which is good. I want you to practice that tonight. And then tomorrow, after we go through a few more examples of this, you'll be ready to try some on your own. Okay. So first we had to get everything on one side of the inequality. So we 0 on the right. Then we had to find the zeros and undefines. That's the next step. Then you put everything on your sign chart and you test the regions. Are my outputs positive or negative? And then the last part is really answer the question. Look at your sign chart and answer the question. Those are the parts. That's the main steps. Okay. All right. I'm not going to have time to do another example, unfortunately. So I'm going to stop here. I'm going to stop recording.